So first, I will describe what was Joule Dalton's theory to characterize the atom. First, we could say that Joule Dalton's theory was the first complete attempt to try to characterize the matter in terms of atoms. So, he based his work in two very important laws: law of conservation of mass and law of constant composition. Law of conservation of mass establishes that mass cannot be created nor destroyed; it can just be modified. So, law of constant composition. What does it says? It says that in a given compound, all its samples will keep a same proportion. It will keep a ratio. For example, if I think in a molecule of water, the molecules of water, it always keeps the proportion 2 hydrogen, 1 oxygen. So basically what his theory says is that all matter is made of indivisible atoms, and also that all atoms of a same element are the same in proportion and in form. What is the problem with Joule Dalton's theory is that he didn't know about isotopes, for example, or about subatomic particles. So his theory had to be modified. Now I will describe the three subparticles of an atom, which are protons, neutrons, and electrons. First, protons. Protons have a positive charge. They are located within the nucleus of an atom, and their mass is approximately 1 MeU. Now, neutrons. Neutrons have neutral charge. That's why they are called neutrons, and they doesn't have charge, and they are also located within the nucleus like the protons. Finally, the electrons have a negative charge, and they are located outside of the nucleus.
For you to calculate protons, electrons, and neutrons, we need to know the atomic mass and the atomic number of the element. The number of protons and electrons is always equal to the atomic number, and the atomic mass is a combination of protons and neutrons. There is a difference between the calculus of a neutral atom and a charged atom. In the example, the neutral atom of phosphorus, the atomic number is 15 and the atomic mass is 31. So when we calculate the protons, electrons, and neutrons, we get that protons and electrons are both 15 and the amount of neutrons is 15 subtracted by 31, so we get the amount of neutrons of 16. In the other hand, we have the charged atom of phosphorus. It has an atomic number of 15 and an atomic mass of 31, but it is negatively charged by -3. So when we get the protons, electrons, and neutrons, we conclude that protons are 15, electrons are 18, and neutrons are 16. For we to get the electrons, if it is negatively charged, we add 3, and if it was positively charged, we subtract 3 from the amount of electrons. Isotopes are the different versions of the same element that have different amount of neutrons because they have a different masses. So we're going to use the example of chlorine-35 and chlorine-37. So the first one, chlorine-35, it has a mass of 35 and an atomic number of 17. So when we calculate the protons, electrons, and neutrons, we get that protons and electrons are 17 and neutrons are 18 because we subtract 17 from 35. And in the chlorine-37, the atomic number is also 17, so protons and electrons are 17 and neutrons are 20 because we subtract 17 from 37.
The average atomic mass of an element is the sum of the masses of its isotopes multiplied by the natural abundance of each one. Now, this is closely related to the natural abundance of an isotope, because in the calculus of average atomic mass, you will have to use the abundance of each isotope. Now, the average atomic mass is given with the following formula. Now, let's use the example of boron. Boron has two isotopes, boron 10 and boron 11. Now, utilizing the formula, we have 10 times 0.19 plus 11 times 0.81, which gives us approximately 10.81.